I'm very happy to see you and give a talk this nice workshop. Especially thanks to Professor for inviting me. Today I'd like to talk a fundamental talk and very easy talk about contact geometry. The contents as the first item is the the name contact, and secondly we review briefly the contact Riemannian geometry, and finally I will state a small result on flow symmetry. First, the name contact. I read the manuscript. The origin of the name contact seems to be due to surface Lie. Actually, in his paper of 1872, I could not remember the title, so the paper. He introduced the notion of contact transformation. Actually, as a geometric tool to study systems of differential equations, I'll give a simple description of contact transformation by using the so-called Huygens principle. First, we prepare some basic materials in XY2 plane. We define a line element or contact element by PLP. Here P is the point in XY, arc XY, and LP is non-vertical P line through P. Point P and P. And then the union of P, the union of LP, P belongs to R2, can be identified with R3 by XYS. Here S the slope of L, identified with R3. Define in this space eta ty minus stx. Then actually it gives a contact form. Then contact form. Actually we compute eta wedge theta. Then we have something like this. It's no vanishes. So we can see that this is a contact form. We consider in particular for a curve gamma in R2 is given by a function y equal fx, and we consider the tangent lines along gamma. So we have y equal fx, and at each point tangent lines like this, x, y, y prime, y equal fx, gives a so-called Legendre curve of eta in R3. I omit the precise definition of Legendre curve. This is Legendre curve. Now I'd like to give a brief description of Huygens principle. For a source, actually the so-called Huygens principle is derived from the wave theory in optics. From a source, there is a primary wave, gamma, say gamma. Then by Huygens principle, each point on the wavefront is the center of a secondary wavelets, like this. And then, enveloping the circular wavelets, we have a new wavefront, gamma t. Continuing this process, we have a wave propagation. Like this way, wave propagation. We write at this point xy, and this point x bar, y bar. Then this propagation moves from xy to x bar, y bar, keeping the same slope of the tangent line. As the same slope of tangent lines. Actually, we established the following equations. Y bar minus y is minus s1 x bar minus x, and x bar minus x, y bar minus y. We assume that the velocity is 1 and t fixed. We have the following two equations, and we may write x bar is x. From this equation, we can easily derive these two equations, t and y bar as t and s bar is s, the same tangent slope. From this, actually, we get dy bar minus f bar is dx bar is dy minus s dx. Namely, it preserves the contact form. We call it a contact transformation. Then the Reeb vector field psi is determined as round by this relation d eta psi equal 0 and eta psi is 1. Actually, this direction is the propagation direction. Note psi, the Reeb vector field gives a propagation direction. This is all I'd like to use the origin of the name contact. The second item is contact Riemannian geometry. I briefly review. For a given contact form eta, I mentioned previously, by these two relations, we determine unique vector field psi, we call Reeb vector field. Then there exists the Riemannian matrix G and one type tensor field phi. It is a well-known fact. And here eta and G are related by the metrical dual, and phi satisfies this equation. Here I is identity transformation, and G and pi have the following relation. Then we always find that L psi eta is 0, which means that psi generates contact transformations. This is always holds. We easily verify this fact. In particular, M satisfies this. This means that psi Then there is isometry. We call the psi killing vector field. And definition, G is a K contact metric. Finally, consider reflow invariant problem. Symmetry. We can consider several reflow invariant problems. For example, M is a three-dimensional contact manifold. If M satisfies psi S is 0. S is a Ricci operator on M.
This operator means the
Yeah, Reeb connection. Yeah, I use Reeb connection. Operator with respect to Reeb connection. Then M is K contact or locally isometric 2 SE2 SL2R with a left invariant contact metric structure or a flat manifold. I would like to omit the detailed proof because I used only a local computation. And I'd like to stop today's talk.
Are there any questions, comments?